All right, so what do we do in order to add fractions? What do these need to have in order for us to be able to add them together? Common denominator. So they don't have a matching denominator right now, so I'm going to need to do some multiplying. The easy way to do it is to take whatever, oh, way too big, our other denominator is. We're going to multiply that on this side, like 1. Whatever the other denominator is, we're going to multiply on this side. 5 over 5. Because I'm not changing my fractions. I can't just multiply by 3 on the bottom or by 5 on the bottom. I have to multiply by 1. It's just the weirdest shaped one ever. So we're going to wind up here with 3 over 15 plus 5 over 15. Once we have that common denominator, we can add together the numerator. So we can do our 3 plus 5, which gives us 8 over 15. So if you have entirely different denominators, you can just multiply whatever your denominator is. You don't always have to go quite that far, though, because sometimes there are pieces that are the same. Because on this next one, I could multiply this one by 2 over 2 and this one by 4 over 4 and get to a common denominator of 8. That is absolutely valid. I could also notice that these are really, really close to each other. If I want to get this one to have a denominator of 4, all I need to do is multiply this piece by 2. I'm just going to multiply by the missing piece. I just need them to match. I don't need them to be gigantic. So we're going to have this be 3/4 plus 2/4. Once the denominators match, we can add together our numerators. 3 plus 2. This is also known as 5/4. And the very bottom one is this very similar vibe to the top one. I need to get my denominators to match, so I know I'm going to need to multiply this one by 3 and this one by 7, but I can't just multiply by denominator, so we're going to multiply it by 1. So this is going to give us 9 over 21 plus 49 over 21. And 9 plus 49 is going to be 58.
That reduces down to 2 and 16.
Does it? That's what I was just checking. I haven't checked that. 58 is not divisible by 3 or 7, and those are our only factors of 21. So that one will not reduce.
No, I'm saying like, it's like a mixed number. Not
Oh, to a mixed number. Yeah, you can do that if you want to. Which would be 2, if you want to. You don't have to. If you put it as a mixed number, we should get 16 21st. This is an if you want. We're not going to do anything with mixed numbers, but since it was brought up, those are valid. They're valid. Like, that's a thing. You can do that if you want to. I'm also 100% okay with an improper fraction, because we're not going to be doing this with just numbers. We're going to be doing this mostly with letters. which means we're not going to have a mixed number to make it. Questions on adding or subtract or adding fractions? Okay. Let's just separate our different problems. So just like the last couple of days, this leads us into what we're doing today, where we're going to add and subtract our rational functions. So those fractions that have all those variables in them, yeah, we're going to add and subtract those suckers. We're going to add those today. Keep saying add and subtract. And just like yesterday's multiplying made this overcomplicated with this little lettery introduction. If you just want to have a seat wherever, we're getting started on notes. All right. So just like with regular fractions, our rational expressions can be added, subtracted if they have common denominators. So today we're going to be working with the adding, and tomorrow we're going to work with subtracting, just because these have a lot of work to them and they get a little annoying. So we have to make sure that we have common denominators in order to be able to add and subtract. That's really what we're looking at here. And this is just putting into letters what we just said. We're going to take our denominators and multiply against the other one. So when we look at the middle here, they multiplied by 1, which was d over d. They multiplied by 1, which was our b over b here. To get those common denominators, we multiplied by 1 that was shaped like the denominator. It's a weird looking 1, but it's a 1. And we're going to start out with an easy one, and it'll just kind of slowly ooze its way a little bit harder. Okay, so our first one, I'm going to zoom it in. First one looks like this. We have x plus 5y over 24y plus x plus 2y over 24y. And so what we're going to do is we're going to say, oh, I noticed this is addition, so that means I need to have common denominators. We look at our denominators and say, all right, do they match? Yeah, they do. So I don't need to do any work to make a common denominator here. We're just going to take it as our 24y. What we need to do next is we're going to take our numerators and we need to add them together. X plus 5y plus x plus 2y. And then we're going to simplify that top because that looks like a hot mess. 24y. So when we simplify our numerator here, how many x's do we have? 2 x's. How many y's do we have? 7y. I'm going to rewrite that x because it's 2y-ish. There we go. So once we have those common denominators, we're adding together the tops. So this one gave us the common denominator. And that's as far as we can go. We can't simplify this any further. So this is our answer. Let's look at our next one. So we have 7a over 4b, and we're going to add 4c squared plus 10. So they weren't nice enough to give us common denominators here, so we're going to have to find our own. If we ignore the b for a second, what would be our common denominator for 4 and 10? 40 would work. Is there anything smaller? 20 would work. So you don't just have to multiply by the denominator. You can. Absolutely fine. We could do 40b, but then we would need to simplify at the end. If we don't want to have to simplify, go for your least multiple. So I'm going to aim for that, for the 20. So my least common multiple of 4b and 10 is going to be 20b. So this is what I'm going to aim for my denominator to be. So on this one, I need to multiply this. I need to multiply my 4 just by 5. So my numerator is also going to get divided by 5. For my right-hand fraction, to get to that common denominator of 20b, we need to multiply by 2b. 2b. So let's simplify each of these. We're going to do our multiplication here. This is using yesterday's where we multiply across. 5 times 7a, 35a, over 20b. And we have 4c squared times 2b. So we're going to have our 8c squared b over 20b. And now we can add these two together to make one fraction, where we have our 20b on the bottom. And I can't really combine them together, so I'm just going to list them. So we have our 35a plus 8c squared b. Questions on this one? Because this is the first one where we really had to make our own denominator. Okay. So here's our next one. We've got 20 over x plus 200x over x squared plus 20x. And I know it looks a little weird. I did some editing because I genuinely hated that problem that was there. So we need to get these to have common denominators, which means the very first thing I need to do is figure out what pieces are missing, what we could do to get a common denominator. So what I'm going to actually do is I'm going to factor this piece. So I can see what I need to multiply this by to make this. So when we come to factor this fraction, I'm going to put it back into its fraction form, and I'm just going to write it underneath. I'm going to factor this. This has a GCF of x. If I factor an x out of both of those terms, we get x plus 20. I put my 200x on top. And everything else is the same. I just factored the bottom. That lets me see that, all right, these both already have an x here. That's great. But this one has an extra piece that this one doesn't. So what we're going to need to do in order to make ourselves have common denominators is I'm going to multiply this by the weirdest looking one we've ever seen. I need the denominator to have a piece that's x plus 20. But I can't just multiply by x plus 20 on the bottom. I have to multiply by 1. Questions on that step? Because that's, I feel like, the weirdest step in this. All right, so then we have common denominators. Our denominator is x times x plus 20, and we can leave it in factored form. I am totally happy with that. In our numerator, we have our 20 times x plus 20 plus 200x. We can leave the denominators in factored form. We cannot leave the numerator like this. We have to be able to combine like terms. So we are going to multiply that out. So in my numerator, we're going to have our, ooh, wrong pen, 20x, that's this guy, plus 400 plus 200x, and all of this is over our x times x plus 20. I'm going to scooch this over just so I can have a little bit more space. There we go. Because I need to come through and I need to combine my like terms in my fraction here to get it as simplified as we can. Where I now have my 20x and my 200x. So we're going to have 220x plus 400 over x times x plus 20. And it's gross But that's our answer. So we're going to need to factor sometimes to be able to find our common denominators. Yeah, let me just pass. Okay. Here's another one. Zooming it in just so you can see it better. Okay, so we need to look at this and figure out what pieces we need. This one looks bigger than this one, but it's really hard to tell what pieces we need when it's in this form. So what we're going to do is we are going to come through and we are going to factor this to make it be a product. That way we can tell if we need to multiply this side by something. So when we have quadratic expressions, we are going to factor. So just like we did yesterday with our x, we have our a times c, 1 times 1 is 1. My b is 2. What is a pair of numbers that multiplies to make 1 and adds to make 2? 1 and 1. So again, using that trick from yesterday, when our a value is 1, those are the pieces in our factored form, x plus 1 and x plus 1. Then we're going to bring down our x over x plus 1. And we're going to look at these denominators. So I'm going to zoom this in obnoxiously far. What is this one missing that this one has? Another x plus 1. So we need this to have another x plus 1. But I can't just multiply by x plus 1 on the bottom. I have to multiply by x plus 1 on the top as well. So that's going to give us our x plus 1 as a common denominator. And we can take each of these numerators and write them down here. We're going to have our 1 from the left-hand one. And then we're going to add our right-hand one. This pair, x times x plus 1. And I'm going to multiply it out. So we're going to have our x squared plus x. So then I'm going to simplify this one more time simply by rewriting this into a better order. And if you want to, you can write this as x plus 1 squared in the denominator, or you can write it as x plus 1, x plus 1. I don't really care. But our numerator is going to be x squared plus x plus 1. All right, so here's our next one. Oh, sorry, I thought I'd held the page. This is our next one. 4 over x plus 1 plus 2 over x plus 2. We need to make a common denominator. I don't have any factoring that we can do here. Oh, sorry. There we go. So what we're going to do is we're going to say, all right, I see these pieces. To get a common denominator, my common denominator is going to have both of those pieces. X plus 1 and x plus 2. In order to get there, I need to multiply this left-hand one by x plus 2. But I can't just multiply the bottom by x plus 2. I have to multiply the whole thing by x plus 2. On the right-hand one, very similar. I need it to have an x plus 1 in there. But I can't just multiply the bottom by x plus 1. I can multiply by 1, even if it's a weird-looking 1. This will give me this common denominator. These two fractions will mean the same thing. We need to look at our numerators. So we have 4 times the quantity x plus 2, which if I multiply this out, we're going to have 4x plus 8. Then we're going to take our 2x and our 1 over here. So we're adding in 2x plus 2. And then we're going to simplify this. My denominator is going to be my x plus 1, x plus 2. And my numerator, I'm going to simplify. 4x plus 2x gives me 6x. 8 plus 2 gives me 10. So your first step is going to be to figure out what your denominator needs to be. You're going to multiply by what you need to have there. And then we're going to combine our numerators. Questions on these?
So if they have like a single thing variable and a coefficient, we can do that?
Be more specific.
Like, so since they both have x plus 1, and then on the other side they have x plus, and then the coefficient also plus 2, will we always be able to do that? That's how it's set up?
That they have the same letter? Or like
both number.
so if they have the same number and letter, that would be something like this. What we did on the last one where we had the x plus 1 but we needed to have the same number of pieces as well. Yeah. Okay, so I gave you guys the homework for this yesterday. On the backhand side, numbers, it looks like the evens, most of the evens, and 13 are addition. So you can practice our addition. Tomorrow we're going to do subtraction. It's really, really similar. So we're going to work on this more tomorrow. Yes, son. Yep. Mm-hmm. Thank you.